Next speaker is Michael DeBra. Michael has been our GPS maintainer for many years in ArduPilot. He's also our smart battery maintainer, and he was recently nerd sniped into becoming our scripting developer. And the way this happened is we were discussing scripting on a development call, and Michael made the mistake of making a comment saying, I reckon I could get Lua going before the end of the development call. So of course he did, and at the end of the call he said, I've got my first script running. Congratulations to Michael, maintainer of ArduPilot Scripting. And Michael is from Swift Radio Planes SRP Aero in the United States.
Yeah, at some point I'll learn to stop saying I can do things, because then Trent goes, great, you're in charge of it. GPS stuff, and then that was mine now. So what do we want scripting for? Just from a use case perspective, there's a couple of main things we can do with it. There's a lot of stuff that's in flight code right now that's very specific, and we try to cover all vehicles, but it doesn't work well. So for example, something like camera triggering, that can easily be moved into scripts. We can be uploading polygonal fences as part of the script and say, when we're inside a region of interest, let's take photos. When we leave it, let's not do it. Without having to upload extra waypoints. You know, there's this thing where GCSs will upload waypoints, and we blow through 800 waypoint missions easily. You know, missions I fly, I can't actually do that way, but a script could say, hey, are we inside it? Let's take photos. We do stuff like fail-safes, and this is one of the main ones that everybody wants. Everybody wants better fail-safes. So we can actually be using this to say, all right, based on the remaining battery and our recent consumption of power, how far are we from home? We have a landing waypoint planned. It'll take us this long to fly a landing mission based on our parameters. We know that this is our wind on plane, and we can actually look at that and go, okay, we should do a fail-safe now. Based on everything we're seeing, we should do it now. On Copter, potentially we could actually hook that into smart RTL, and we could say, okay, my plan says it should take this long. It's going to be a little bit expensive to compute that. We don't need to do it that often, though. And again, this is something that we can do at this outside layer, and you can tailor that to your vehicle without having to be generic for everything. Other use cases would be flight modes. So a nice example is like the zigzag mode PR that came in recently. That could easily be living inside a script where you want to go. You could actually be computing your survey grids on the aircraft on the fly. You probably want to geofence them for safety reasons. But from a performance perspective, there's no reason I can't compute my next waypoint just in time. And as I'm doing that, I can actually be modifying the mission to account for wind and optimal camera configuration settings. Or if I hook that to my camera script, I could actually go back and say, okay, my camera script says I didn't get a photo. I didn't get my feedback event, let's fix this. And we can actually handle that automatically on the autopilot without, again, having to hard code all of this. Because I write all the features I want in C code, but it's not going to translate well to everybody else, and it's not going to be easy to add that. Other use cases, people have a lot of interest in stuff like channel mixing surfaces. So same way you can do mixes on your radios, like OpenTX comes to mind a lot. You can be running these kinds of scripts on the autopilot as well for arbitrary channels or non-standard vehicles. One of the other ones that comes up a lot is right now that Maverick serial pass-through to update GPS drivers. We could actually be doing all the firmware upload of a GPS driver on the autopilot automatically for serial ports. Instead of having to use this Maverick method that's not very robust, UCenter has a reasonable chance of failing with that. There's no reason we can't say, hey, run the script once, take over the UART port, update it correctly, and then unload the script and we're never paying for it again. Other stuff that comes to mind is custom logging. As somebody who does a lot of photo mapping, again, I want actually a separate file that just has the data I want in it without having to download these 300 megabyte logs every time. Or if you're trying to do a test flight and you want something that's just some very specific data without having to put it into the whole AP logging structure, you can just add it there directly as you need. And this is one of those ones where I can probably keep making up use cases forever, but I think we've roughly covered some interesting reasons to look at this. So the path forward for this is looking to be Lua at the moment. There's a couple of reasons for that. One is because I'm marginally familiar with it from the game side. Two, I hate Python, so I didn't want to look at MicroPython. Dismissed it and moved on. And the JavaScript options scared me even more, so I'm going to stick with Lua.
Burl.
No, I don't care. Totally happy. So looking at Lua, and then on Lua's side, there's actually a couple of debates. Lua has been around for so long, it's so easy to embed it. There's actually a variety of systems for it. So there's Lua, there's LuaJIT, there's eLua, which is designed to be embedded. So eLua sounds great because it's designed to be embedded at first, but you quickly come to the realization that what eLua is really giving you is it's giving you a hardware abstraction layer that's easy to port to hardware, and runs Lua as the primary thing. As ArduPilot, we already have a great hardware abstraction layer. We have everything else we want already. We don't actually want eLua running it, so looking at Lua looked to be a good path forward to start with. And LuaJIT, while it's great performance, there's no reason for us to be running JITs on the ArduPilot. We don't have that kind of space to be running that flash-wise. So we need this to fit on our hardware. And, we've got the nice ChipBus space free, so we're probably going to eat it up very quickly. The faster we can take it, the better, because that's how all memory goes. Whoever gets it first gets it. So current status, after having nerd stumped myself into this, I can run it on both CIDL and ChipBus at this point. Ironically, even though ChipBus isn't designed to be POSIX compatible, it was actually a lot easier because it provided more POSIX stuff than NUTX did. So I had a lot more of the POSIX defines I needed. So running that right now without a lot of effort on optimization, we are running in 86 kilobytes of flash and 12 kilobytes of RAM running, and that's with a very short script loaded. Running that on, and all these numbers are before the recent ChipBus Part 3 stuff was merged, but this is all on a FMU v3 queue. And we can garbage collect in 2 milliseconds for 11 kilobytes, and that's using 64-byte allocations for that garbage collecting time. So it's relatively small chunks. If we're using larger chunks, we'd be collecting faster. So there's a couple things to note on this. One, by default, Lua, and I'm using Lua 5.3, which is the first version of Lua that brings in integers as well as floating point numbers, so we can actually have integers or floats, which from an ArduPilot side and latitude longitude coordinates is actually exciting. Having to do everything with floats there causes a lot of precision problems. So, but using this and using the 32-bit mode on it, so instead of using doubles and 64 bits, which is the default. And the other one is that we haven't cut out a lot of stuff. So I've cut most I/O stuff yet, because that part of ChipBus I don't have F-write easily available, or reliably available yet. But this is including stuff like coroutine libraries, which are probably going to be cut in the end. But for now, it's just including pretty much everything. I've just commented out code until I can compile and actually run scripts usefully. So main things we want to see out of this is we want to run multiple scripts. If you can't run multiple scripts, it's not that exciting. If I can only have my camera run or my failsafe script, that's a really harsh decision to ask a user to make. So we're looking at loosely following the OpenTX model. I want to make a disclaimer now that I don't use OpenTX at all, and I've never worked with it. So I've looked at this briefly from the outside, but my pass-through experience is all game side. So if you don't think this works from an OpenTX experience or any other reason, please let me know. So what we're looking at doing here is we're going to take the scripts, we're going to run each script in its own environment. So inside Lua, at top level, your global environment table where your symbols like OS, time are loaded, for example, we will give each script its own environment, and that way if it makes a global symbol, script A and script B can't have a conflict, because asking people to get their namespaces right won't happen. But with this, we'll be using a meta table on that top environment so that when you start Lua, you get a Lua stack object. We don't want to duplicate the stack object. That stack object weighs in around 7.5 kilobytes right now. So if we had to have 7.5 kilobyte stack of RAM for every script we want to run, that's going to be a very quick limit. So what we'll do instead is we'll give a meta table for the common OS libraries, everything like how to get the GPS position from ArduPilot. That will be a meta table that's an indirection layer. So every script gets its own environment. Every script can have their own global state variables. But everybody's looking at the single copy loaded for the ArduPilot reference, so that we don't burn memory on it. So within each script, you're running your own environment, you can create your own global variables. You really shouldn't do that for the most part for a lot of performance reasons in memory, but you can. But because every script will be running on the same stack variable, when we hit a low memory pressure, we can garbage collect from any of the running scripts. If we run into the separation problem, you actually get into a situation where script A is really close to garbage collecting, has a ton of free memory, but script B can't look inside of its state. It doesn't know what's happening. So by running inside of a single stack object, we're going to be able to collect from it. But what this does mean is we need to be able to run each script on the same stack object, and Lua does not provide any features for parallel processing. So to do this, every script is going to run in a given time slot, and if it takes too long, we're going to hard kill it. For the record, that is what OpenTX is doing, so we at least know some people can handle this approach to programming. So what you do is you say, I'm going to run in this time slot. And for a given time slot, you try and complete. When you're done your completion, you'll return a time to be rescheduled and possibly a function pointer. Like, please run me again 300 milliseconds from now. Or don't ever run me again, I'm happy, I'm good. So when we do this, we're going to get into basically its own scheduler, where it's just going to say, run this script, and run that script, and run this script. But it allows us to run them all very briefly. And then at the same time, because we're moving to a model where every script gets chunked into short time slots, we could register for callbacks. And we're not going to get callbacks unless scripts return their own execution at some point. So by doing this, we can say, hey, on a data available on UART1, serial 1 is nomenclature B, let this script run whenever I'm ready for data. and otherwise the script isn't going to be scheduled, it's just sitting around. So this is roughly what I'm looking at. It should be noted this is basically proof of concept. I've done multiple scripts with infinite loops, and I've time sliced them and killed them, and that's worked well. I haven't implemented anything along the schedule line, but from a time slicing, chopping, and then swapping which one's running, that does work reliably and safely. We'll have to address the question of what do we want to do if a script doesn't complete. If your script is never completing its time slice, at a certain point we should probably give up on it, because your script is clearly not going to finish and we're just wasting our time. But at this point, that's an open question for the future. The other main issue outstanding right now, outside of general cleanup, is API hooking. So how do we want to actually expose ArduPilot features? I want to get the GPS position from AHRS. How do I get that? So it's straightforward. It's very easy to write the function. This is what I've done thus far, to say, get the information, push it to the stack. It's really easy to write that. But it is a pain to ask a developer to say, hey, expose every function you care about into this library. If I want to push the GPS position, it's about 20 lines of code right now with minimal type checking. So if you have to write, every time you want to expose a new function to scripting, if that's 20 lines of code to write, that's going to be pretty painful. Nobody's going to want to do that. So we'd like a way to do that easily so that people can update and maintain the API without having to go insane. I don't want to be the person everybody goes, hey, I had a new feature, can I get it in scripting now? And then wait for me to get time to work on it, because that's not going to happen quickly. So this would be really easy if we were a system like Java. If we could do runtime reflection when you say, hey, AHR's location, and then look up and go, oh, AHR's location happens to be type int, and we know where to grab it from. But we don't have a runtime reflection system at all. So from that, what we're going to have to end up doing is either manually do it, or create a macro system where you say, hey, I want to load this from this object field, it's this type, and we know how to automatically convert that. And that is what a lot of other people have done in the past. It's a common example for games with C++ engines, for example. But we are going to have to figure out the macro system for that, and that still leaves you saying, I want to expose a new function, I'm going to have to update the macro lines for it. I don't think that'll be a big issue, because that's much of what we do right now for the parameter system. When somebody says, hey, I want a new parameter, they just magically copy the previous one that happened to work, put it down here, and update the appropriate values. So as long as we get it right the first time with reasonable examples of how to read everything, I think it'll be okay. The other question is how do we want to expose data inside a script? So there's something that comes up is in Lua, basically everything falls into a table. You can treat tables like arrays or named value access. But what you get to with this very quickly is if I want to deal with a location structure, so locations have latitude, longitude, altitude, and flags, I can push this to a table and I can access the table.location, and it's all pure Lua data. Lua can collect it, and I can allocate it on the fly, I can construct one myself, and then I could pass it back to a handler that converts it into our location struct. Or alternatively, we could be exposing the location structs where we say, hey, us as the API side will do all memory management of this. When you say garbage collected, I'll free it if it was on the stack or something. And then we use metatables to look into it. Metatables will be a lot faster for us, but it will result in situations where, for example, the flight mode where I want to fly survey grid, I want to make it on the fly. I can't just make my new location table. What I will have to do every time is I'll have to say, hey, ArduPilot API, give me a location structure. Okay, now go set these fields on the location structure. Because I won't be able to just build that myself on the fly. So it's a trade-off either way. I suspect we're going to want the user data approach for two reasons. One, performance, and second one, just being memory. Constructing those tables on the fly is going to be expensive. And then if you want to use a function like geofence, check if I'm inside the fence in this polygon, we don't want to be converting that into structs every time and popping it off the stack. So we're probably going to be looking at user data, but it is going to be a limitation to what you can do on the scripting side. So to do, minimize the patch set. A patch that's me going around and just killing lines and files all the time is not going to be the final and safe solution, especially when we want to say bring in Lua 5.4 once that's out. That's just a massive diff right now. So we need to minimize the patch set and also work out a lot of the Chibios stuff that does or doesn't need to happen. For example, some of the error no stuff in Chibios, it's just like if you kill it, everything works. So I don't know why we've redefined some stuff, but we need to figure out why some stuff was redefined, because everything seems to work without it. Provide a better allocator. So this one's actually interesting. One of the nice things we do in ArduPilot is by default, we zero every malloc call. So in theory, you should never have to worry about garbage data. The problem is in a scripting language like Lua, where it already does its own memory management, it's actually a waste of time to malloc. So everything goes through realloc, so we do a memcopy, but before we malloc and then memcopy to it. But because we did the malloc, we clear everything, so we spend much time zeroing all the data out. So we can skip this zeroing step for just Lua, because Lua safely is going to handle that itself for us, and we're not gaining anything by doing that behavior. So there's a fair amount of performance we can win there, which will help the garbage collection times come down. Actually implement the scheduling stuff I was talking about before. I made it sound like it was there, and that's just a theory on how to do it right now. It's not done. It's not even close to done. And then move everything to a dedicated thread. So right now the proof of concept is being called from a 1 Hertz tick and plane loop. There's no reason you'd ever want to run scripting from your 1 Hertz loop and plane, or anywhere else for that matter. So we need to move it to its own thread. We also want that to be truly its own thread, not the I/O thread, because that is the easy place I'll probably throw it first. And then Peter will get complaints about how come people are killing my data flash thread. He's just going to love that one. And then actually hook the ArduPilot API. There's also a question of, do we want to hook every piece of the API? Because conceivably we could actually move to, instead of doing macro systems where people implement it themselves, you could actually automate everything with a preprocessor for the whole project that exposes everything to Lua. My first guess is that we really don't want to do this for a couple of reasons. One, users, somebody writing a script, it's not safe to let them say, hey, Ahars, go reset yourself, go set your origin somewhere on the fly. It's not really a feature you probably want most users to have access to. You don't want them to be able to call scheduler.halt by accident. So things like that we don't want to give them. And also if we move to a system where the macros, for example, we could scale a lot of data. So right now we have stuff like locations where altitudes are multiplied by 100 and stored as centimeters, which is great. Which one is it?
No, we're going to get rid of that.
Okay, well we're getting rid of that. But so for a number of places outside of that, we do have that approach right now where things are decimal multiplied out and access to it. And while I agree we should get rid of it, until then, for a Lua script, if we ask people to magically know that this value came to them in centimeters, if we should work in centimeters or not, that's a bit painful. So we could actually, for now, move to pre-multiplying some fields out for them, and then do the reverse in the opposite direction, which should be a lot nicer quality of life. Because even right now, for myself at least, when I'm looking through the API, I go, oh man, that just came out totally wrong because that was actually a centimeter call in that API. That's why that went really badly in Citadel. I'd like to not be doing that. I don't want users to have to deal with that. And actually upload scripts. So scripting is easy when you hard code it into the stuff to launch, but that's pretty boring. So we actually need a couple things on script uploading. We need a good manner to say, I want to run scripts X, Y, and Z for users to do. Because we don't have any mathematical stuff that even approaches saying, what do I want to run? The param system where we normally overload all of our behavior all the time, regardless if it fits, doesn't even come close to fitting anymore, because I can't say, go load file something. I can't even fit a string into a parameter, so I can't do that. So parameters are out, and they're also limited and just wrong. So I don't know how we want to transfer scripts up. The current thought I actually have that might be interesting is if we have a init.lua script that lives on the SD card. That's your boot script, same way you have .bashrc or something on a Linux system. So you can just add files there as you want. And then we'll probably want a Matlab command that says, hey, go launch this script. Just put this into the queue. And at the same time, GCS authors will have to figure out a way to upload files to the ArduPilot. So there's a Matlab TP protocol, which other than knowing that it exists, I haven't looked at, and I know ArduPilot doesn't support it yet. So we're going to need to find ways to get these things up there. For now, just sticking files on the SD card is probably fine. Long term, we'd like to move away from that. And very long term, we have the same way we can now do parameter appending to the firmware with APJ. It'd be great if I could say, I want to append this script to my flash image. Don't put it on my SD card, let me just access it off my flash image, because I know when I build my board, flash this. I'm always going to long and available, and I don't want to have SD card access concerns. I can just assume it'll be there. So that would be really nice, especially for ArduPilot, if we say, hey, if we actually move camera stuff to be in a flash Lua script, users who actually do camera mapping load it, that saves us other space in the rest of the system at runtime, because it's now an opt-in or out, and it's appended to the end, so we can use it as we want. But again, it's not been done, we haven't looked at it, and we're going to have to figure out if we want to be caching scripts or not, because running the Lua compiler is relatively expensive. Compiling short scripts right now takes me about 1 millisecond for a very short script, but that is a one-time cost. But it's worth considering on startup reasons. Do we want to be pre-compiling these once and then saving them somewhere? For now, I don't think it's worth chasing, but it is something to keep in mind. So from there, having just blathered on about scripts and isn't really going to be available anytime soon. Are there questions that should be addressed?
So I know this is all new and you're kind of hard-coded stuff, so nothing like this is developed yet, but what do we expect this to look like from the user perspective? Is this like something going to be embedded into Mission Planner, or a separate tool, and then they write something up?
So a lot of how the user deals with it is pretty undefined at the moment. The idea of putting scripts on the SD card and then having a init script, that's pretty straightforward as far as users can access SD cards themselves, copy to it. And that is much the world of OpenTX, for example, because you just put stuff in and it's magically launched and then you can use the menu system. But for useful things, I think we're going to be looking at something where GCSs will have a way to upload random scripts. So it'll probably be another setup page, and you should be able to enumerate the scripts we support right now. Because at some point you're going to go, oh, I don't want that script on the ArduPilot anymore. I do want this one, I don't want that one. So we're probably going to be moving to something where the user can enumerate and say, this script, yes, no, and have a date for it. As far as script launching, if we move to that RC style one, we don't really want to be doing file editing, so we might FTP the file down, edit on GCS, and re-upload. But I don't have an idea what that should look like, so I'm open to suggestions.
We've talked about NavFTP before. Is that something that might be more practical with GPLs coming in? Is that be useful for dumping stuff like this in?
We could use NavFTP as a transport, but I don't think NavFTP is suitable as the interface that the end user sees. It could easily carry the data, just like there's multiple ways of carrying the data. We want something more like the mission interface, but with multiple missions, multiple scripts with names, and probably an activation tick. You might want to have multiple scripts on the vehicle, but deactivate them for this flight.
Yeah, so how we deactivate stuff like that, it's pretty undefined. When I talk about, I want to do flight modes of scripts, that's great, it's easy to say. It's easy to say, this one script is hard-coded for it. But how do we allow users to say, oh, I want to fly this script on this flight? If I have two scripts that can do missions, how do we know which one to control? How do we know which one to go to? And very quickly, somebody's going to go, that's great, I love that I can do missions. Can I use a switch now on my transmitter to pick which script I'm running on the fly? So we're going to have to figure out how to present those things to users. But again, that's the fact that we can get to that question. That's a very powerful feature for end users.
Have we kind of thought about how this affects licensing? At the moment everything's on V3. Is this going to enable users or vendors to have bespoke closed functions within ArduPilot?
So there's a couple interpretations. My point of view is it is a scripting language. You are running your own script on it. I don't see a reason why we would be opposed to that. If somebody wants to add on a custom feature that enhances it, that's great. The fact that we'll allow people to run whatever scripts is perfectly fine either way. There's been some discussion of should we require always running the compiler on the ArduPilot, that way users can at least see the code that they're running and modify as needed. But from a licensing point of view, I'm of the opinion we should be allowing proprietary license code on that scripting interface. And there is value if you're going to give your code to somebody to run on it, to provide its source version, because I make no promises that, especially in early days, API won't change. Your compiled bytecode might suddenly break one day, so you might be needing to look at it from a compiling point of view. But I think we should be allowing custom stuff.
Yeah, and to extend that a little more, the way I see it is the scripting is almost like a mission, where it's just not really we have a parser, but the content is just not in the repo. So what we might want is a new repo of examples, or we have typical all kinds of fail-safe scenarios, and you can load them all or just one, and then you can also supply your own custom ones. So we might want to create a new repository just for script management.
Yes.
Do you have an example of a Lua script? I've actually never seen one before.
So, because I use weird, stupid window managers, I didn't plug my laptop in easily. So, I have, let's see, I can figure out how to make Tridge's laptop work.
Alt-Tab or Escape probably to get out, and then find a web browser in the top left. So there's a Firefox there. If you Alt-Tab around to it, you should find a Escape to get back out. Yeah.
No,
Do you want me to
which is still in the, yeah, if you want to drive, that'd be great.
Yeah. Michael and I have been doing a lot of discussions about how we're going to integrate, and one of the things I'd really like to see is our missions, where an individual mission item is a script. So we still have a mission editor, but the script registers a new mission item type. So we've got nav waypoint at the moment, or nav RTL. There'll be nav script 1, right? And it will call out to the script and do whatever the script, make it do a loop the loop, whatever, And then when it's completed, it moves on to the next item of the mission, which means our mission gives us a way to logically progress items, and the script is not dealing with the entire mission, it's dealing with that one item, right? With a initialization function, a call function, and a have I completed function, like we have in our C++ code. Does that make sense? Yeah. So, excellent. There's a script.
So this is a terrible, terrible script. But from this point of view, we've declared local variables A, B, and C. So local variables are valid for your function frame only. They don't escape to the global state. And because Lua is a register-based machine, it's actually a lot better to be working within local variables for performance. People actually do stuff like unloading the function math.sign to a local sign function, because it's just faster.
Just so people understand, this part is the script. This is all C++ around it.
So this GPS.location, so GPS is a table that I've loaded from the ArduPilot side, so it's actually pointing at the ArduPilot GPS object. Location is building a table on the fly. This is not doing the user data approach. I'm actually manually pushing a table to the stack that says this is the field location, longitude, latitude. And then from that, once I have a table, that's the address of the field and table. So that's just looking up the field with alt as the string index. All tables are hash map based. So then here, Lua provides something called multiple return values. So in C, C++, I can only return a single thing to you. In Lua, I can actually return a tuple to you with as many things as I'd like. So what I'm doing here is, this is, again, param function is a table. I've pushed the function get to it. So that's doing parameter lookup, which is one of the slowest things you could be doing on ArduPilot code. So that's looking up the parameter stat runtime. The extra escaping is just because I'm compiling this in as a hard-coded string. So that looks it up. Found is being returned as a boolean of do we have the value or not, and then value is containing a float field with it. There's a couple ways of addressing error handling in Lua. Again, because I have limited Lua experience, I'm feeling my way towards it, but this is an example of let's push multiple values and see what happens. Again, GCS syntax using string.format. Ironically, Lua 5.3 at this point ships with UTF-8 library. So even though we're wasting space on UTF-8, we'll probably keep supporting it, because minimizing that patch set when I looked at it was a pretty large effort to go back to ASCII. It's only weighing in around 1 kilobyte for the entire string library. So we will be UTF-8 compatible. And then this is just an infinite loop, because I was testing the killing stuff. So it gets stuck down there, eventually I kill it, and the main process continues. But more interesting scripts will come. And again, the OpenTX is not a bad spot to look. It's a little bit funky, because again, you have this time window requirement. And that's probably going to be the hardest one with Lua scripts for new users. It's very nice to say, oh, wait for this condition to be true, sleep in the loop. With this version of time slicing, where you have to strictly return, you won't be able to do that. So you have to say either call this function instead, or you'll have to have an event handler on the outside. But given that we've been doing that safely in the OpenTX world and people have been able to handle it, I think it'll be okay.
So since you're able to interact with the ArduPilot, it seems like you could have information leak out of it, like passing things into the variables. Is that right? You can actually set your loader radius or something.
Yeah. So if we give you stuff like param set for something, you could be setting it, or if we give you the API for it.
Okay.
So it'll have to be stuff like param set, for example, could be really dangerous if you do something silly from a script, but you can do something silly from a GCS.
So what the powerful part of this is it runs off real-time data. So you could do things like turn left if the wind is higher than 3 meters per second. Otherwise, turn right and turn sharper or something.
Yeah, so you can do stuff like that. And the other one that this is really nice for is, NSH console is pretty rarely used right now. It's going away. If we ditch NLX, NSH console is gone. Lua in a REPL type mode in its own environment is a great replacement for the console, especially if we have full API exposed. In NSH right now, you can't do stuff like, hey, Ahars, what's your location? You can't just poke it. You can't say, change this on the fly. So if I can actually have this exposed to a GCS in a REPL-like interface, that's going to be powerful and exciting, especially for testing new hardware.
There's an example script in OpenTX. So it has like an init function, has some output variables, input variables, and a return. It doesn't actually do much, but yeah. So there's a wizard script. Sorry, should have been better prepared with the examples.
Telemetry scripts is what you want to look at. That's the other one.
Telemetry scripts.
Which is going to be pretty similar. Empty body.
Yeah. Right. All right. Insert code here.
Yeah, so we'll probably end up with a similar, this is a template, and here's some basic examples.
So with things like the Solo Smart Shots that require a co-computer at the moment, things like that, they're scripts.
Yeah.
Is that the sort of things we're doing this?
Yeah, that's exactly the kind of thing you'd like to be able to do with this. As long as you're not spending too much time on it, if your co-computer is trying to compute a bunch of, I'm this far away, this is my corner pixel, this slant, something silly like that where you're trying to keep constant pixel stuff and it's really expensive. As long as you're not trying to do anything that level, you should be fine. And that's where I'd like to take this. I think I can do fail-safe monitoring, camera triggering, and survey grid computation on the fly without needing a companion computer piece of hardware. And for me, that's quite exciting.
This combined with the new configuration for the waypoint, for the position controller too, would allow significant functionality in sort of script-based navigation too.
Yeah. Yeah, and it's potentially, if you want to just prototype, like, does this flight mode even make sense? You could potentially be using it for that. Like, just before I go any further, let me just hack this together and see what happens. And then if we need performance later, we can get performance out of it.
And I don't see why we wouldn't limit this, but we could add scripts and edit scripts during flight. Maybe
Yeah.
while we're executing the script, but
So the only thing you have to be really aware of then is that compiling a script is always going to be slower, and it's much more memory intensive. So if you want to recompile something on the fly, you're going to interrupt the scheduling of your other scripts. But you're not doing this very often, so it shouldn't be a huge issue. But if I have a large script, and let's say it takes me 10 milliseconds to compile it, it's on a background thread, which is fine, but if I was somehow dependent on tight scheduling of my other scripts running, it might fail. Or depending on memory pressure, if something's allocated a bunch of memory, it might fail.
so right now, if you just fill up with scripts on boot, there's this resource hit on each one.
Yeah, exactly. So from a generic point of view, I probably don't want to be modifying my scripts once I'm armed. We can probably do it quite safely, but I don't do a lot of things once I'm armed, generally, for exactly that reason.
But we support changing missions and all kinds of stuff. So I think we should probably at least try to make sure.
Yeah, functionally, I don't see a reason to lock it out. I'm not sure what we'll see as the upper end of compiling time. But again, anything that's running at a script layer, we have to accept fundamentally it might not compute in time, or some other script may have consumed most of the available RAM, and my script is going to fail, not because I've used up my RAM limit, but because somebody else used up the Lua RAM limit. So at certain points, we're going to get scripts that fail, we'll try and restart them, but we're still going to never always need a level of, flight mode script failed, ArduPilot has to do something sane. Plane that might be RTL, cockpit might be hover where I am. Or, it's never going to remove the need for the plane to kind of know, hey, low voltage battery failsafe, let me go try a landing. But at a higher level for the outside loops of control, it gives us a lot.
So does that mean there's going to be a life cycle of each script?
What do you mean?
Like in Android, there's this huge life cycle chart of your active, your sleep mode, you could resume back, and the different levels of resources.
No, because your environment, if we're letting you run in your own environment where you can make global variables, your environment has to stay valid. I can't really unload your environment elsewhere because Lua is rearranging its memory when it does garbage collection. So if your scripts, once your script terminates and you say, don't ever queue me again, yeah, we're going to get your memory back. But if your script is going and ongoing, I can't really do much to reduce your memory footprint safely.
But can we have like a repeats or calling some another scripts in cases of this or that?
Yeah, so you get, when you say like, hey, return and schedule me again this time, you can say, don't ever schedule me or schedule this other script.
So then how sandboxed will we make this? Can a script talk to another script?
No. So script talking to another script, now we need inter-process communication or the same namespace. Letting people into the same namespace is just going to be a disaster for a lot of reasons. So we can eventually maybe come up with a reasonable inter-process communication, but I'm not seeing good arguments for it yet, especially with everything else we need to solve first.
That's what I was thinking with the parameter. Like we pass variables, but it'd be a nasty way of doing it.
Why does everybody hate the parameter system?
No, I'm just saying. Passing in and out and.
Yeah, that's an abuse. It's an abuse. So proper inter-process message passing needs well-defined semantics. Setting flags in params and hoping that they're valid or that they get picked up in time, it's just going to lead to heartache and frustration why we have random and undefined behavior. So if we really do want to move into this, I think we're going to need a proper message box system, much the same way you'll see something like Erlang pass messages between processes.
CBOS has that actually.
Yeah, I was
All right, so we
picturing-
can leverage that then.
I was picturing some like special script that you can optionally load that you can just like dump stuff into and read from that any script could have. It has special root access or whatever.
Yeah, so you can look into that. But again, because they're going to be message box named, unless you load one script from the other script, you're going to get into a situation where now, again, we need to make sure we don't have a naming conflict. If Tridge and I both have scripts that are called, awesome function pass one, and we both use that same destination, now we're going to have collision.
It's already the namespace declaration for the script. So by default, the script gets its own namespace, but you can actually say, I want this script to run in namespace Michael. Right?
Yeah.
And the other one also runs in namespace Michael and can share variables.
Yeah, so we can always give A-level namespace like that. My main concern is that if you get into the realm of let me copy, paste, modify scripts, users are always going to violate it on us.
Yeah.
So I'm scared of giving people the ability to shoot themselves in the foot that freely. That's kind of my point of view. I'd rather, we're an autopilot, we're flying something through the air. Let's limit your ability to shoot yourself in the foot and address it some other way.
Fantastic. Well, thank you very much, Michael.